Okay, we need to do a little bit of work on solving equations with logarithms in them. So this is kind of first port of call. So I have log to the base 2 of x plus 4 equals 1 plus 2 log to the base 2 of x plus 1. The thing that you must never, ever do is just decide to cross off your logarithms. I've seen some interesting things. You have to follow the laws of logarithms. So the first thing really is to combine your logarithms together. And so the first thing I'm going to do actually is subtract the logarithm on the right hand side, like so. Then, following laws of logarithms, first thing I need to do is bring up any powers. So log to the base 2 of x plus 4 minus log to the base 2 of x plus 1 squared. So I'm bringing up that power. Then log A minus log B is log of A over B. Once logarithms are combined together into one logarithm, I can now undo this using laws of logarithms. First law of logs that we did, this is the base, this is the power, and that gives us x plus 4 over x plus 1 squared is equal to 2 base power to the power of 1. 2 to the power 1 is 2, so x plus 4 is equal to 2 lots of x plus 1 squared. Multiplying out the right hand side, you get 2x squared plus 4x plus 2, and then combining all of that together, if my example has worked okay, I get 2x squared plus 3x minus 2 is equal to 0. There's a little bit more going on with that, but nothing new. It's just combining everything together a little bit more. Part B, we actually want to solve this equation, which on the surface seems really straightforward from there. There's just one thing you need to look out for. So from A, we know that 2x squared plus 3x take 2 has to equal 0. Factorising that, you can use your calculator to solve this. I just don't have mine on me. So it's going to be plus 2 minus 1, which gives us x equals a half, or x equals negative 2. The only thing you need to be careful of, this is a really minor point, is that these are solutions to your original equation. We're solving this equation here, and something we haven't spoken about yet is that you can't log a negative number. If you think about it from our first definition of logarithms, if you've got an exponential function of the form a to the b is c, where a is a positive number, then if you think about the sketches of your exponentials, they were either growth or they were decay, but they were always sitting above the x-axis, which means that the value of the function is always above 0. So c is bigger than 0. It can't equal 0. 0 is your asymptote. What that means is that you can't log 0 or a negative number. You will get used to this. If you try and do log of a negative or 0 on your calculator, you will get a maths error come up. What that means is if I put this back into my original equation, that's fine, because I'll have log to the base 2 of 4.5 plus equals 1 plus 2 log to the base 2 of 1.5, which is absolutely fine. I can put x equals a half into here. But if I try and put minus 2 into here, minus 2 plus 1 is negative 1, and you can't log a negative, so this is not a valid solution to the original equation. You should make that point, and it doesn't come up very often. It is a minor thing, and so there's actually just one solution to this equation, and that is that x equals a half.